Half a day students. So for today's lesson, we're going to be covering factoring, and this will include factoring out monomials, factoring by grouping, factoring trinomials, some special factorizations, and factoring completely. We'll go straight into some examples, but first, we're going to be reviewing the distributive property of multiplication. And this is when we have something that looks like this, where we have a times a binomial, b plus c. And as you know, what we're going to be doing is distributing that a. When we do that, we're multiplying it to each of the terms within the binomial, so AB plus AC. The whole point of factoring out monomials is basically we're going from this to look something more like that. So we're doing the opposite of the distribution. So when we want to factor this polynomial from the example, negative 4x squared y minus 4x plus 12xy squared, we want to first look at what each of our terms have in common. So I know all its coefficients are divisible by 4, and each of them have at least one x, so that's what I'm going to be factoring out. Firstly, there's going to be two different ways to do this. One might be preferable to the other in certain circumstances, however, both are completely fine. So I can factor out that 4x like I said, and the interior is just going to be basically divide each of the terms by 4x. So negative 4x squared y divided by 4x gives us negative x y. Negative 4x divided by 4x is negative 1, so we have minus 1. 12xy squared divided by 4x gives us 3y squared. So that's actually one example of a possible answer. Another possible factorization of this polynomial is actually to factor out negative 4x. So a lot of the times people don't really want to be left with a negative as their first term. So a good example would be to factor out negative 4. So we can actually factor out negative 4 from this whole thing. That way I'll be left with xy. Now that this becomes a positive 1, and then we're left with negative 3y squared. You'll notice that it only changed the sign of everything on the inside. Both of these are perfectly fine factorizations. Moving on. Factoring by grouping. Factor the following. So looking at letter A, factoring by grouping, essentially we're just grouping it into two different binomials, factoring a monomial out of each of them, and then doing another step after that. So first thing I'm going to do is group my things. So I'm going to group 5m and 5n together, and then cm and cn together. I'll do that by just drawing some parentheses right here. When you have a plus as your middle term, an addition sign in the very middle, it's very easy. All you have to do is just draw the parentheses. So now I can look at 5m minus 5n and see what they have in common. I know they're both divisible by 5, so I'm pulling out 5. I'm left with m minus n. For my binomial on the right, each of them have a letter c, so I'm taking out positive c. And again, I'm left with m minus n. And you'll notice, wow, if these two are the same, basically what I'm able to do is now group these two together and multiply it to m minus n. And that's the complete factorization. So that's only if the binomial inside of the parentheses are the same for each of them. For this one at the bottom, there's a minus sign there. What I actually want to do is keep that minus sign with the x squared t. And I can do that by changing it to plus a negative. So minus something is the same as plus a negative. So we have 5t minus 20 plus negative x squared t plus 4x squared. Okay, so I'm just keeping that same value the same, but now I just have that plus in the middle, and I'm able to group them without changing any values. Okay, for this first one, I'm going to factor out 5. For the second one, notice I want the t to be positive, right? I want to match whatever's inside the parentheses. So I'm actually going to factor out negative x squared as opposed to just x squared, because I do want to have that t be positive. I'm trying to match them. Okay, so 4x squared divided by negative x squared is actually going to be negative 4, so it works out well. Since these two are the same, I'm able to group this 5 and x squared. Don't forget the equal signs. 5 minus x squared times t minus 4. Factoring by grouping. Moving on to the next example. Let's look right now how to find the product of two binomials. So we already know when we're multiplying binomials, what we're going to do is FOIL, right? We take the first terms, then the outside, the inside, and the last term. So it's going to come out to x squared plus 4x plus 5x plus 20. Combining like terms, I'm left with x squared plus 9x plus 20. Okay, you'll notice that multiplying two binomials, I'm left with a trinomial there, right? So basically when we're factoring trinomials, again, we're trying to go from the trinomial back to a product of binomials. So in order to factor these trinomials here on the bottom, what I'm actually going to do is look at the signs. The signs become very important. The sign of the third term, first of all, I want to make sure it's in order, right? We have the x squared, the x, and then the number. I want to look at this sign right here. Since it's positive, I know it's going to be the same sign. And I'm looking for a sum, okay? And since this is positive, they're both going to be positive, and you'll see what I mean in a minute. Now we're going to actually look at the factors of each of our first and third terms. The factors of x squared are easy. We just have x and x. Factors of 20, we have a few. 120, 210, 4, and 5. So that's where these come into play. Same sign, sum. I want to see what factors of 20 will give me a sum of my middle term, 12x. So I can see 1 plus 20 is 21, 2 plus 10 is 12. So I'm actually going to use that. This one, there's only one to choose from. And there is this little cross multiplication way that I do. It's not super necessary when you have these easier ones to factor, meaning that there's no number in front of x squared. But the more we get used to it, the easier it'll be to factor the ones with a number in front of x squared. So we have x and x, 2 and 10, both are going to be positive. X plus 2 times x plus 10. The way I'll check my answer is to x times 10 becomes 10x, x times 2 becomes 2x. Adding these together, 12x. If this is the same as your middle term, then your factorization is correct. So we're actually going to have x plus 2 times x plus 10. And please box your answer. I know there's going to be a lot of work all around. Make it easy for you to find your answer. Okay, looking at this second part of example 3, we still have a same sign and we're looking for a sum, but now they're both going to be negative. So this one we can actually do probably without checking. So we know it's x and x. There's only one to choose from. 1, 4, 2, 2 for my factors of 4. Which one of these will give me a sum of 5? I know it's going to be 1 and 4. So it's actually going to be x plus 4 times x plus 1. And if you want to absolutely double check your work, just FOIL them and then you should get the original expression. Example 3, factoring trinomials. So now we're doing a couple more. Now notice we have a minus sign over here. The other ones meant that it was going to have the same sign and we're looking for a sum. Now it's going to be different signs and I'm looking for a difference. Meaning, what factors of 30 pairs of factors of 30 will give me a difference of 7. So again, I'm looking over here. X and X, factors of 30, 1, 30, 2, 15, 3, 10, whole bunch, right? 5, 6. You don't have to list all of them. Once you have one that suits it, then you can actually use it. So for this one, 10 and 3 give me a difference of 7. And now that, you know it, this actually will give us the sign of the bigger number. So the bigger number is going to be positive. So this is going to be x plus 10 times x minus 3. And again, we can do that little cross multiplication thing. That will be helpful to us later, right? We have 10x minus 3x, which gives us 7x. This whole thing basically saves us from having to do the whole FOIL in order to check our answer. It's essentially just the OI in the FOIL, so the outside inside. These two numbers are basically the two that you combine in the middle of the expression when you're multiplying. Looking at letter D over here, same thing, different sign. I'm looking for a difference. Now the bigger one is going to be negative. Find factors of each. 1, 15, 3, 5. Okay, which one of these will give me a difference of, actually, I believe this is supposed to be 14. I'm sorry. Okay, so it would actually be 1 and 15. X and X, so that's going to be x minus 15 times x plus 1. Moving on. Now we're going to look at a special case called the difference of squares. Okay, so first thing we're going to do is try multiplying these two binomials. Notice they're very similar, except their difference is in the sign of our second term. So multiplying these, we're going to FOIL. We have x squared minus 3x plus 3x minus 9. Notice that these two actually cancel each other. We have a positive and negative of the same term. So I'm left with x squared minus 9. So we have a product of binomials that look a certain way, and then when I multiply them together, I'm left with x squared minus 9. So this will actually lead us to the difference of squares. So if you have something in the form a squared minus b squared, it only works if it's minus. It'll actually factor out to a plus b times a minus b. I suggest you memorize this. This is a very important formula, and it will help you with a lot in the future. So using this example, x squared minus 36, a good thing to do would be to write it as an actual difference of squares. So I'm actually going to write it as perfect squares. So x squared is just x squared, 36 is 6 squared. And then from here, it's easy to identify my a and b, right? We know it's just x and 6, so it comes out to x plus 6, x minus 6. And the more you use this, the less you'll actually have to be writing it in that form where it's x squared minus 6 squared. The second one, note that it also works when you have other variables and when you have coefficients to the variables, but the coefficients also have to be perfect squares. So this one I'll actually rewrite as 5x squared minus square root of 16, I know is 4, so we have 4y squared. So I'm able to write this as 5x plus 4y times 5x minus 4y using my difference of squares formula. Factoring polynomials now of a higher degree, so now we have ones of x to the 4th power. So basically what we're doing is the same thing. The only difference is that now I have a different factors of my first term. So I'm still doing the same sign sum. They're both still going to be positive, but now my factors of x to the 4th power are x squared, and my factors of 9, 1, 9, 3, and 3. So if I was to choose from which one of these will give me a sum of 6? It'll obviously be 3 and 3, right? So what I'm going to do is now set this up. X squared plus 3 times x squared plus 3. So this is the fine to present your answer like this. Another way to write it, notice that they're actually exactly the same, so I might be able to write it as this. X squared plus 3 squared. Nicer way to represent it, but if you do leave it in the other way, that's completely fine. But it is important to know that these two mean the same exact thing. Moving on to letter B, x to the 4th minus 16. Notice that each of these are perfect squares. So whenever you have a variable raised to an even number, it's a perfect square. So this is actually just x squared minus 4 squared. There again, we're using the same difference of squares formula, where it's going to be x squared plus 4 times x squared minus 4. Okay, it's important to note right here, whenever you're dealing with these x squared ones, you want to take one last look to see if there's anything that you can factor out one more time. So notice here, x squared plus 4, there's no special formula to factor that. Whenever it's plus, you cannot do it. However, when it's x squared minus 4, x squared is a perfect square, 4 is a perfect square, so I can do one more application of my difference of squares. So this first one's going to stay the same. This second one, however, is going to become x plus 2 times x minus 2, and that's again using the difference of squares one more time. Okay, moving on to our last example, factoring completely. So these are ones, you notice we have much higher numbers. The higher the numbers are, the more difficult it is to do. So basically what we're going to do is first look, what do each of them have in common? So 12, 36, and 27, all of those numbers are divisible by 3. So I'm actually going to factor 3 out of this first, and it'll make it much easier to factor. 4x squared minus 12x plus 9. From here, I'll factor whatever's on the inside. If you want, you can factor it on the side. Sometimes I like to factor it on the bottom here, where it's out of the way. Okay, so same sign sum. I'm looking at the factors. So we have 3 and 3, 1 and 9. We have 4x and 2x, or 4x and 1x now, sorry. And then we have x squared, 2x, and 2x. So from these, that's where our thing where we do our cross multiplication comes in handy. I do want to stress that typically, unless your numbers are especially high in the middle, so 12 is not too far from 4 and 9. So if it was like 30 or something like that, I might use the 4x and x, or the 1 and 9, the more extreme numbers, or the more extreme pairs. But for the most part, I usually find it a good place to start at the numbers that are kind of close together. So those are a good place to start. So I know they're both going to be positive. They're both going to be, or sorry, they're going to have the same side. They're both going to be negative. So I'm going to try this. 2x minus 3. 2x minus 3. And when I cross multiply this, I have negative 6x, negative 6x, which comes out to negative 12x when combined, which is the same as my middle term, so that actually is the correct factorization. So we have 3 times 2x minus 3 times 2x minus 3. And again, like the last one, we said that there's one nice way to write this, where you write 2x minus 3 squared. Okay, for letter B on our last example, what I want to do is actually look at these and see, okay, is there anything else I can factor out to make it a little bit easier for me to factor? So 16 and 64, they're actually both divisible by 16. So I'm going to factor out 16, and then it's going to be way easier for me to factor. Oops, sorry. 16. I'm left with x squared minus 4y squared. From there, I can see again, look in my x squared minus 4y squared. I want to check if it's a difference of squares. X squared is a perfect square. 4 is a perfect square. Y squared is a perfect square. So this is actually something I can use. I can apply the difference of squares formula to. So this I know is going to come out to x plus 2y times x minus 2y. And that's it. Perfect. Okay, so I hope you did well. I actually have I probably will be